How do you calibrate a DAC to reduce inaccuracies? Imagine you're trying to get a perfect sound or a precise measurement from your electronic device. If your digital to analog converter is off by even a little, it can cause big problems. Calibration is the key to fixing that. First, you need to understand the types of errors that can happen. Offset error is when the output voltage isn't zero when it should be. Gain error is when the slope of the output versus input isn't what it should be. Differential nonlinearity means the steps between digital codes are uneven, and integral nonlinearity is when the overall output deviates from a straight line. Next, set up your measurement tools. Use a high-resolution voltmeter or an analog-to-digital converter to check the DAC output at specific digital input codes. Make sure to measure at room temperature or the temperature your device will operate in, because temperature changes can affect accuracy. Now for the calibration process. Start by measuring the output to points near the minimum and maximum digital input values. These are your calibration points. Calculate what the ideal voltages should be at these points. Then, find the gain correction factor by comparing the difference between the ideal and measured voltages. The offset correction is the difference at the low end. Adjust the digital input codes or the internal settings to correct these errors. To fix nonlinearities, measure at multiple points across the entire input range. Use those measurements to create a correction table or a polynomial function. This helps your system know how to adjust the digital input to get the right analog output. Some advanced DACs have built-in self-calibration features. These can run automatically at startup or during operation, using internal references to adjust for drift and mismatch. Perform calibration at the temperature your device will work in, because temperature shifts can cause errors over time. If you can't control the temperature, do a baseline calibration and update it regularly. You can automate the calibration process with a microcontroller or digital signal processor. Store the correction factors in non-volatile memory so your device remembers them every time it powers up. This is especially useful in precision applications like test equipment or motor control. When calibrating, use a stable and accurate voltage reference. Keep your measurement set up free of noise and interference. Also, consider the architecture of your DAC, because resistor string and current steering types might need different approaches. In short, calibrating a digital to analog converter involves measuring the output at known points, calculating correction factors for gain and offset, and compensating for nonlinearities with lookup tables or polynomial adjustments. Some systems even have self-calibration features to keep things accurate over time and temperature changes. Doing this ensures your DAC produces the precise analog signals your project needs.